Good morning, everyone. My name is Jitin Tyagi, and I'm here to present my research paper. And its title is Non-Destructive Bulk Bit Classification through Near Infrared Hyperspectral Imaging and Deep Convolutional Neural Network. And the paper ID is 2250. This is the outline of my presentation. First of all, I will give the brief introduction about the technique, motivation, materials and methods, methodology, results and discussion, conclusion and future work, and then references. Now the introduction. Near-infrared hyperspectral imaging is a non-destructive technique that captures the internal information of the target object without causing any damage or harm to it. It combines the advantage of both machine vision and spectral technology. Basically, it simultaneously determines the chemical composition of heterogeneous data and the spatial distribution of chemical constituents. The entire information captured by the hyperspectral imaging camera is stored in the form of three-dimensional hypercube, which contains tens or hundreds of continuous light wavelength indexed spectral bands. This is the structure of the hypercube, which contains three coordinates x, y, and lambda. X and y are called the spatial coordinates, and lambda is called the spectral coordinates. In this hypercube, we can see that there are a large number of wavelengths, and each wavelength represents the unique property of the constituent particle. Now, the application of hyperspectral imaging. Hyperspectral imaging is basically used in agriculture, remote sensing, biotechnology, environment monitoring, food sector, pharmaceuticals, and medical diagnosis. In agriculture, basically it is used for the varietal classification of seeds and identification of any kind of disease in foods and leaves. The motivation behind this work is that wheat is widely consumed food all over the world. Traditionally, the wheat varieties are identified by the experienced professional persons using morphological traits, color, and textures. Few chemical methods are also used, like Zeldal method and high-performance liquid chromatography, but these methods are very destructive in nature, time-consuming, and require costly equipments. So automation in the classification of seed is very important. Recently, hyperspectral imaging technique in conjunction with computer vision is providing very excellent result for the classification of the seeds. Materials and method. In this study, we have collected 12 Indian wheat varieties from 4 locations in India, and around 150 to 200 gram of seeds were collected for the image acquisitions. These seeds were collected from the certified wheat grower institutes in India. Image acquisition setup. Figure C is the hyperspectral imaging camera, and its spectral range is 900 to 1700 nanometer. The main components of the camera are spectrograph, lighting assembly, linear translation stage. Basically, linear translation stage is the area where we place the plate containing the seeds for capturing the image. And the all components are enclosed in the dark chamber. The dark chamber was used to avoid any interference from the external light. In this study, we captured 2 images per variety, and each image contains 3 bulbs, and each variety has have 6 bulbs. So total number of bulbs were 72. After capturing the images, the intensity value of all images were corrected by the equation 1, and its formula is IC is equal to I raw minus I dark upon I white minus I dark into 100. I raw is the intensity value of the raw image. I dark is the intensity value of the dark reference image. I white is the intensity value of the white reference image. The dark reference image was captured using by capping the mouth of the camera, and I white was achieved by using the white correlation time. IC is the corrected reflectance value. Dataset enhancement using the data augmentation technique. In this study, the hypercube contained 168 spectral bands, but due to the noises in the first 10 and last 6 spectral bands, we discard all those spectral bands. So in this study, we used only 152 spectral bands. And first of all, the region of interest was find out before the data augmentation. And for getting the region of interest, we selected the 60th band out of the 152 spectral bands. And also thresholding technique was used to create the binary mask. And after creating the binary mask, this binary mask was multiplied by all the 152 spectral bands for getting the region of interest. After getting the region of interest, we cropped the images of size 30 by 30 by 152. 152 is the number of spectral bands. And in this case, we put a constraint, and that is we put only those images in our data set in which the area field ratio was more than 90%. Area field ratio means the space occupied by the seed part only. So after cropping the images, we applied this constraint. And after that, we applied four data augmentation operation: random crop, random rotation, random zoom, random flip. And after applying the data augmentation, we achieved 900 images per variety. And our data set contains a total of 10,800 images for all 12 wheat varieties. This is the pipeline of our proposed methodology. In this study, we used 3 deep convolutional neural network for the classification task. Since we get after data augmentation the image size 30 by 30 by 152. This deep convolutional neural network was designed for handling the RGB images of size 224 by 224. So we resized the augmented images using the bilinear interpolation. And after the resizing, the image size was 224 by 224 by 152. In this study, we find out the results of two kinds of data: raw data and pre-processed data. Raw data means we have not applied any pre-processing technique to the raw images. And in this case, we used two pre-processing techniques, and their names are standard normal variate and multiplicative scatter correction. Standard normal variate basically used to normalize the spectral information, and multiplicative scatter correction is used to remove this any kind of scattering effects caused by the light. This scattering effect was caused due to the different seed size and different internal chemical composition of the seeds. The models were trained for the 200 epochs. Results analysis. These are the results which we obtained after training the models. And we find out that GoogleNet with MSC pre-processing technique achieved the better results as compared to other models. And the test accuracy, the best test accuracy was 95.12%. This is the performance metrics of different models. And in this case, we can see that GoogleNet with MSC achieved 0.95 precision, 0.95 recall, and 0.95 F1 score. This is the confusion matrix of the GoogleNet with MSC pre-processing technique. And in this case, we can see that there are a large number of zero. There are more sparsity. That means the proposed model classified the 12 wheat varieties without any misclassification. These are the epoch versus accuracy curves. And in this case, we can see that as the number of epochs are increasing, the loss is decreasing. And training accuracy and validation accuracy are also increasing. And after certain number of epochs, that is 70 epochs, the curves get converged. It means that there is no overfitting in the model. This is the comparison of our proposed work with the existing work. In this case, we can see that Unlers and et al. Performed classification of 4 wheat varieties using CNN SVM model, and the model got 98.1% accuracy. And our proposed work achieved the 99.12 accuracy for 8 varieties and 95.12% accuracy with 12 wheat varieties. The accuracy of 95.12 is less as because our data set is very complex and the number of varieties is larger than as compared to other works. Now the conclusion and future work. This study demonstrated how the deep convolutional neural network traditionally used for RGB images were applied for hyperspectral image classification. In this study, a dataset of 12 wheat varieties was captured using the hyperspectral imaging camera of wavelength range 900 to 1700 nanometer. In this case, we find the results of two kinds of data: pre-processed data and the raw data. And in this case, we use two pre-processing technique, SNV and MSC. The CNN-based models, including GoogleNet, ResNet 34, LensNet 121, were used for the classification task. And GoogleNet with MSC pre-processing technique achieved the highest accuracy of 95.12%. And in future, we will expand our dataset and we will capture the images using two kinds of modality: hyperspectral imaging camera and RGB camera. And our primary objective is to compare the performance of deep learning model and incorporating the intention mechanism for the classification task. And further we will uh, compare the result obtained by the attention mechanism with the existing work. These are the key references. Thank you.